Welcome back to the virtual class of Milestone College. Dear students, today I am going to teach you a creative question of organic chemistry. This is actually aromatic part of organic chemistry. Look at the whiteboard. The first one is phenol is heated with zinc dust. If phenol is heated with zinc dust, then benzene is produced here. And again, if sodium benzoate is heated with soda lime, then benzene is produced here. And again, A compound indicates actually ethane gas, because if I put here the value of N, I will get the CH triple bond CH, I mean ethane gas. If ethane gas is passed through the iron tube at 400 degree centigrade temperature, then benzene is produced here. Dear learners, from those three reactions I can understand that B compound is actually benzene. Then look at the another reaction. Benzene reacts with methyl chloride in the presence of dry aluminum chloride. Benzene reacts with methyl chloride in the presence of dry aluminum chloride. To produce toluene and hydrochloric acid. And again, benzene reacts with nitric acid in the presence of sulfuric acid. Benzene reacts with nitric acid in the presence of sulfuric acid to produce nitrobenzene and water. And third one is benzene reacts with chlorine in the presence of ferric chloride. Benzene reacts with chlorine in the presence of ferric chloride to produce chlorobenzene and hydrochloric acid. So, dear students, it can be understood easily that C compound is actually toluene. C compound is actually toluene. D compound nitrobenzene, and compound E is actually chlorobenzene. Then through the Dow process, P compound is produced here. Now my question, what is Dow process? Actually, in the Dow process, chlorobenzene reacts with sodium hydroxide. Chlorobenzene reacts with sodium hydroxide in the presence of at 300 to 400 degree centigrade temperature and 150 to 200 atm pressure to produce sodium phenate or sodium phenoxide and hydrochloric acid. This sodium phenate reacts with hydrochloric acid at 180 degree centigrade temperature to produce phenol. So, dear students, I can say here P compound is actually phenol. So, dear students, I think all of you understood about the stem of this creative question. Now question number A. Explain the mechanism of production of compound C or D from the compound B. I mean, here actually it is asked that the production of toluene from benzene or the production of nitrobenzene from benzene, explain the mechanism. So, I am going to show you the mechanism of the production of toluene. Here actually the reaction is benzene reacts with methyl chloride in the presence of dry aluminum chloride, I mean anhydrous, to produce toluene and hydrochloric acid. The first step mechanism, methyl chloride reacts with aluminum chloride to produce methylinium ion plus aluminum tetrachloride ion. Then in the second step, methylinium ion attacks to the benzene ring as electrophile to produce unstable carbocation, I mean sigma complex. Then at the third step, this sigma complex releases proton to produce toluene. This is the mechanism of the production of toluene from benzene ring. Then come to the mechanism of the nitration reaction of benzene, I mean nitrobenzene, production of nitrobenzene from benzene. The first reaction is, first you have to write the reaction. Benzene reacts with nitric acid in the presence of sulfuric acid to produce nitrobenzene and water. At the first step, nitric acid, this is nitric acid. I have written nitric acid as partial structural formula. This is nitric acid, and actually OH of nitric acid combines with the hydrogen atom of sulfuric acid to produce water. Then I can write here nitronium ion, NO2 plus ion plus hydrogen sulfate ion plus water. Then at the second step, NO2 plus ion, nitronium ion, attacks to the benzene ring as electrophile to produce unstable carbocation, I mean sigma complex. Then this sigma complex releases proton to produce nitrobenzene and sulfuric acid. That's all about the question number A. And question number B, explain the preparation of explosive substance from compound C. I mean here the compound C is actually toluene. So the explosive substance, I mean trinitrotoluene, can be produced from toluene. Question number B. This is toluene, compound C. Toluene reacts with nitric acid in the presence of sulfuric acid at 30 degree centigrade temperature to produce orthonitrotoluene and paranitrotoluene plus water, then both of the orthonitrotoluene and paranitrotoluene are mixed together and heated. Again, in the presence of sulfuric acid, down low, at 60 degree centigrade temperature, in the presence of sulfuric acid at 60 degree centigrade temperature, in the presence of sulfuric acid, both of the orthonitrotoluene and paranitrotoluene reacts with nitric acid to produce one, two, three, 4, 5, 6, 2,4 dinitrotoluene, then 2,4 dinitrotoluene, then 2,4 dinitrotoluene reacts with nitric acid at 100 degree centigrade temperature in the presence of sulfuric acid to produce 2,4 trinitrotoluene. This 2,4 trinitrotoluene is shortly known as TNT. TNT is an explosive substance. That's all about the preparation of an explosive substance TNT from the compound C, from the toluene. Explain the preparation of painkiller medicine from compound P. Compound P actually phenol. So from phenol, a painkiller medicine, paracetamol can be produced. Phenol is done nitration in the presence of sulfuric acid to produce orthonitrophenol and paranitrophenol. Orthonitrophenol and paranitrophenol. Then by the partial distillation, paranitrophenol is separated. Then paranitrophenol is reduced by stannous and hydrochloric acid to produce para-aminophenol. Para-aminophenol. Then para-aminophenol reacts with acid anhydride to produce paracetamol. And this paracetamol is actually painkiller. Question number D, which is more reactive between compound C and D? Compound C means toluene and compound D is nitrobenzene. Actually both of the toluene and nitrobenzene give electrophilic substitution reaction. toluene is more reactive than nitrobenzene in electrophilic substitution reaction. What is the reason? The main reason, toluene, in case of toluene, electron donating group, methyl group, is directly bonded with the benzene ring. देखो sound हो गया. In case of toluene, methyl group is directly bonded with the benzene ring, and methyl group donates the electron to the benzene ring. As a result, benzene at the ortho, para and ortho position, the electron density is increased through the resonance. As a result, the electrophile or electrophilic reagent attacks to the ortho and para position of benzene ring to produce the ortho and para product. If I consider here the nitration reaction of toluene, this is an electrophilic substitution reaction. As methyl group is a ortho para director, it produces orthonitrotoluene and paranitrotoluene, and due to the high density of electron at ortho and para position, toluene shows more reactivity in electrophilic substitution reaction. And now come to the another point of nitrobenzene. Nitrobenzene, in case of nitrobenzene, an electron withdrawing group, nitro group, is directly bonded with the benzene ring, and here actually nitro group withdraws the electron from benzene ring, and as a result the electron density of benzene ring is decreased, and electrophile attacks to the benzene ring slowly. That's why nitrobenzene is less reactive than toluene in the substitution, electrophilic substitution reaction. And if I show you the nitration reaction of nitrobenzene, para ortho nitrobenzene is produced here because At the meta position, the electron density is more than the positions of ortho and para. That's all, my dear students, today. In my next lecture, I will discuss about the MCQ questions related with again the aromatic part of organic chemistry.